Good morning, students. This is the lesson of class 9 for the subject of geography, topic rotation of the earth, which is covered in chapter 3, rotation and revolution, starting on page number 32 of your textbook, and is being submitted to you on 26th of April 2021. The Earth, like all other planets in the solar system, revolves around the Sun in an elliptical orbit, and it also spins on its axis. These two motions of the Earth are known as revolution and rotation. Many phenomena on Earth, like day and night, seasons, winds, and ocean currents, depends on these motions. Rotation is the spinning movement of the Earth on its axis from west to east once in 24 hours. Students, as you all know, Earth's axis is the imaginary line passing through the center of the Earth, joining North Pole and the South Pole. This is the axis of the Earth, which is joining North Pole to the South Pole. And it is not vertical, it is inclined at an angle of 66.5 degrees from the plane of ecliptic and 23.5 degrees from the perpendicular to the plane of ecliptics. The Earth completes one rotation from west to east in 23 hours, 56 minutes, 4.09 seconds. This period is termed as the sidereal day. Students, the speed of Earth's rotation at the equator is 1660 kilometers per hour, and the speed decreases towards the poles. Now children, let us discuss about the effects of Earth's rotation. So the first effect is formation of day and night. Day and night are caused by rotation of the Earth on its axis. This is because parts of the Earth facing the Sun have day and parts opposite to it have night. Circle of illumination is the imaginary line showing demarcation between the phenomena of day and night. The second effect is sunrise and sunset. Sunrise and sunset are caused due to west to east rotation of the Earth. So, sun rises from the east direction and sets in the west direction. Number 3, Coriolis Effect. Coriolis force is experienced by any object moving over the surface of a rotating body. Due to Coriolis effect, the winds and ocean currents move clockwise or they get deflected towards its right in the northern hemisphere and anti-clockwise or towards its left in the southern hemisphere. As you can see, this is the launching site and this will be the target. But due to Coriolis effect, it gets deflected towards its right direction from 0 to 15 degrees. There is a gap of almost 15 degrees. So this is termed as Coriolis effect. Number 4, duration of day and night. Duration of day and night is not equal at all places on the earth. This is also because of the inclined axis of the earth. In the northern hemisphere, as you can notice, the day length is more as compared to the southern hemisphere. Number 5, sun, moon and stars seems to move from east to west due to west to east rotation of the earth. This effect is similar to what one experiences while looking at the trees and buildings from a moving vehicle. Sun, moon and stars are stationary and we are moving with the earth's rotation. Number 6, the speed of rotation has created a centrifugal force resulting in a bulge in the middle, that is at the equator, and flattened at the poles. Centrifugal force appears to act on a body moving in a circular path and is directed away from the center around which the body is moving. As if it is being told to you earlier also, the speed of Earth's rotation decreases towards the poles. As if you can notice here, at the equator, it is almost 1650 km per hour, which get decreases to 1550 km per hour, to 1275 km per hour, 830 km per hour, and 0 km per hour at the pole, at the North Pole. Similarly, in the southern hemisphere. This is all because the distance is maximum at the equator and it is going to be decreasing while moving towards the poles. As you all know, speed is directly proportional with the distance. That's why with the decrease in distance, the speed also decreases. Number 7, rotation causes difference in time over various places. As we had studied in earlier chapter, the difference in time is 4 minutes for 1 degree longitude. Number 8, the side of the earth towards the sun gain heat and side away from it loses heat. So, the short rotational period make the temperature variation between the day and night. Now, why we do not feel the motion of the earth? Rotation and revolution are two chief motions of the earth. The force of gravity keeps everything attached to the earth. This keeps all objects at rest with reference to the motion of the earth. Using this principle and Newton's first law of motion, scientists have proved that the earth rotates on its axis. Now, students, this is all about Earth's rotation. Now, let us recapitulate the topic by means of a quick retest. Your questions are: first, what is the direction of Earth's rotation? Number 2, how much exact time Earth takes to complete a rotation? Number 3, the speed of Earth's rotation dash towards the poles. Number 4, due to Coriolis effect, winds deflect to dash in the northern hemisphere. And number 5, what is circle of illumination? So the answers to the above questions are: first, west to east or anti-clockwise. Number 2, 23 hours 56 minutes 4.09 seconds. Number 3, decreases. Number 4, right, towards the right direction. Answer 5, the imaginary line showing demarcation between the phenomena of day and night is called circle of illumination. Now students, your homework is you have to complete this exercise. A part, answer the following. Question number 1, 2, 3, 4, 7 and 16. I hope you all have understood the topic very well. So you all are required to read the chapter at least twice and complete the exercise. With this, I conclude this interactive session. Thank you.